Okay, so 10 things you didn't know about the sun. So sun is actually white, believe it or not. It's the colors that mix around it in the universe that actually cause it to look like it's kind of like yellow, red, or even orange, sort of, if you look at it through like the atmosphere. But really, they've had to take a lot of pictures and convert them over. But without the color manipulation, it's actually pure white, believe it or not. So what that means is the sun actually is a lot hotter on the surface and the core, the further you go into it, of course. And that is, it's at least roughly 15 million degrees Fahrenheit. But it may very well be even more brighter than that. Okay, so here's another one. So about 67 elements to 68, maybe even more, are found within the sun's core to its entire atmosphere. Because what's really interesting is during nuclear fusions and fissions and being the center of the solar system that the star represents, because this is how it is for like every other star, stars are capable of creating their own elements, not necessarily to store inside their own, atmosphere and core, but like eventually, because of how fast everything's moving and, friction and radiation in this case, that's how energy is distributed through the universe. Even Albert Einstein's theory of relativity, which is fact, of course, states that everything in the universe moves and everything moves so fast, faster than we can comprehend it. So with that being said, and because energy, combine that with the first and second law of thermodynamics and the law of conservation, energy only multiplies and it never gets truly destroyed. It only changes so periodically and evolves into something much more and bigger. So this is just another way that the universe recycles everything one way or another, whether the sun's creating heat and then it's also creating like its own solar system based on while holding things in its own orbit, as long as it doesn't go flying out of it at some point and then becoming like what is known as like a rogue star or planet. Surprisingly, a large number of the sun's mass and surface, as well as its corona being hotter than its core, or surface rather, is actually even more complexing. There's actually still a lot of things about the sun itself that we don't even know about, like the material that makes it up, other elements that we've probably never even seen before because it's capable of creating stuff. But it's really interesting how, what's even more bizarre is how it does it though, because, it's mixing, because everything in space moves, but at the same time it's pulling things in and sending it somewhere else. Kind of like how like when the Earth moves, it's like absorbing the stuff in the universe, the dust, as well as dark matter, maybe even transmitting it on this planet, like some sort of like radiation, even though it makes it past like the ozone and all that. So it's strange how science works, but even the reality we live in, like a whole lot of stuff is happening that we don't see, and it's kind of like the same thing with the sun. How many things that the scientists and astronomers still don't know about, what exactly makes up the surface, as well as its physical characteristics and properties, and how much of that we still have yet to figure out. It's actually very interesting. So some of the pictures that you might see, if you actually take a look at it's the ultraviolet light that's actually making the sun look like it's more of like an orange reddish color because of the way it blends in the short period of time it travels. But even though it travels really fast, but it's the photons and the emanating radiation that it gives off different gamma ray bursts that can actually cause like a different kind of frequency that causes it to distillate the photons and the illumination of the light. So it's actually very interesting to think that that's why like we're getting those. It's because of the amount of, it's the bursts it gives off that cause the color distortion, and therefore the amount of light that causes it to mix with our, even like the light and color spectrum that we see. And there's probably an infinite number of colors that we can't even identify, or maybe even our eyes might even be adjusting to something else entirely. Other animals might be different too, but that explains why like the sun gives off like a different color than it should be, instead of the color white that it really burns brightly as. And I think if I remember correctly, blue is actually the hottest color, and white is like the second. So basically the sun is able to transfer from its core about 600 million tons of hydrogen and helium per second from its core. And it's really interesting to think, because that explains why the sun is going to basically swell up like a giant balloon one day. And that's why a lot of scientists say that The sun is going to get much bigger because obviously it's like a balloon, you know, you fill it up with helium, balloon gets bigger. And so there's no other elements that are causing its, like, I don't even know what it's like the reaction of it, rather. That's really the best way to put it. And so that would explain why the hydrogen right now is the most common element in the sun, which is kind of interesting because when you usually think of hydrogen, you usually think of like you think of water, hydrogen and oxygen, for example. But it's like with the sun being as bright as it is and as hot as it is, and the core being as hot as it is, you know, I guess it goes to show you that even hydrogen cells can really be, it's just hot water basically is what it would be. But it's so hot that, you know, it doesn't just cool the sun down, obviously. So it's not pure water because the elements are found there, but they're different. It really is interesting to see, like, you know, what you can really mix, like, especially with like nuclear fusions and fissions, you can really mix a lot of elements around and then you can get so many different results. It's actually really amazing. Like the same thing with like kinetic and potential energy and physical and chemical changes and all the different rearranging of like ion particles and subatomic formulas that you can also get. So basically, a lot of stars are speculated to have arisen based on nuclear fusions and fissions. I mean, as they should, because that's basically the process that gives them such plasma and all that. But what's really interesting is it's really interesting how like nuclear fusions and fissions really can create like what is known as like a dense mass, to the point where it actually gives off it's the appropriate construct, I think that's the right way to put it, of how the sun is. Like, you know, aside from the gravity and aside from the mass that the sun has and all, obviously the nuclear fusions and fissions again, it gives it off the elements it's able to render. And so it's basically just a big giant frenzy of rearranging and burning stuff off and converting it into something else, and then those particles go flying somewhere else if they don't burn them off and just turn them back into something else. Obviously a way to keep planets in orbit, but at the same time create a substantial life force for like photosynthesis and a heat warmer for like the life itself, for when the planet, so like if they don't get what is known as like tide lock between the sun and whatever planet they're orbiting, it basically creates its own, you know, life cycle. So it holds the planets in order, and it also creates the star for it, and buys itself some more time, so that way it can create its own acceleration and force that allows it to exist the way it does. So basically explaining how the sun is able to, you know, maintain such a long life cycle. And what's even other crazy is there's some stars out there that, you know, they don't burn as bright, so they last even longer. I think they're just called brown dwarf stars, maybe. But they don't dim as light. They don't dim as brightly, so they last even longer, like trillions of years, maybe. So when the sun gives off the heat it does, it can deliver at least 4 million milliwatts to the human retina, as well as any other kind of eye, and it heats it and causes temporary blindness. So it's actually, I mean, even though obviously you shouldn't stare at the sun, but it's actually amazing to think that it gives off that much wattage of light, photon, and illumination rather. To think that the human eye can retain so much light, but at the same time, you know, obviously the sun, it burns so brightly. And here's something else to think about. The sun itself burns so fast. That's how fast the temperature rises, and how fast there must be that many nuclear fusions and fissions, how fast they're moving, because how fast they're accelerating also causes the temperature to burn excessively, as well as it will eventually end its life cycle even faster, depending on how many elements it's burning through and how much of it it's burning through. So the sun moves roughly 200 kilometers per second. That's roughly 124.2742 miles rounded, if I got that right. And so that should just kind of give you an idea of how fast the sun is moving, very fast. And also, here's something else I want to throw out there. If you try to look at the circumference of the, like how long it takes to complete an orbit around the Milky Way galaxy, it's actually kind of skeptical, because the Milky Way galaxy might actually be even bigger And all these sizes and speeds might very well still be kind of in development, because they're just, think of them like estimations. There's always, no one can really accurately measure something that's not man-made, like, because the science is way up beyond our understanding in a lot of ways. So it's always just to kind of give you an idea that there could possibly be, it could be faster, it could be smaller. It's just an estimate for the most part. So that's still pretty interesting to like kind of reconcile when you think like how big the universe really is. It's a galaxy could roughly be at least 1.9 million light years, if you even found that one right, versus what was it, like 100,000? Because there's a lot of outdated information, but like, of course, you can't just take a tape measure and run it across the galaxy. It's a lot bigger than it seems. And some of the sounds that the sun gives off. Now, obviously, people say sound doesn't travel through space, and while they are right in a sense, because it doesn't really bounce off anything, but I mean, if you have special instruments, you can actually measure, they do produce like some sort of sound barrier. So what's really interesting is, as far as the sun goes, it actually sounds like a magnet field kind of going off. You can also kind of hear like the solar flares that are being implemented through its, because it's a sea of fire, basically, plasma in this case. And so, or better yet, here's another way to look at it. If you're like a welder, or you actually use like what is known as a plasma cutter to, like if you're, someone like a mechanical engineer, for example, you might actually have been able to see how like some of the sound without like the sound of it grinding, sort of like the sound that plasma makes when it's mixing together, if that even is the right term. You can imagine something like that too, like especially like as it moves in space. But of course you can listen to it online, but you might have to find a couple of them, because there are some of them where people are talking over it, trying to explain it. And there are better examples out there of it, but you will find it eventually though. So the sounds that you hear the sun make and all that all stars produce something. It's usually, the way sound is usually produced, it's usually based on the elements and how fast something moves in space. That's what I've been able to gather. But at the same time though, it really depends on what it is too, even black holes, or even, like neutron pulsar stars, for example. Some of the fastest things in the universe even make sounds. I think even light itself could be, if we could accurately measure it. I mean, aside from plasma being photons and all that, but I don't know if you want to draw a line that's necessarily the same thing, but it's like photons are like more like concentrated light particles versus like plasma, like, it's like going back to like potential and kinetic energy in a lot of ways. Stored energy is much different than runaway energy, if that makes sense. So yeah, if that is not interesting enough, then hopefully this next one will be. And while this one does sound very obvious, but a lot of people should really take this very seriously in some aspects. The sun can kill bacteria. Well, obviously, no doubt, right? But here's something very interesting to think about. If you go outside just for a little bit, but you play it safely, kind of like not to the point where you're killing yourself outside because you can get sunburned, but just go outside every now and again, here and there. And you will be surprised that even if you don't stare at the sun can kill bacteria. They did experiments back in the 1877, for example, and they found out there was a German microbiologist that studied, bacteria, and they figured out that if you were to leave bacteria within salt water, and it was able to, they left it in like a little container where it was cloudy, there was shade, the sun didn't have any light effect. It grew with bacteria. However, once the sun exposed it over time, it was eventually clear water. The bacteria got vaporized basically by the ultraviolet lights, because the sun can kill things, obviously. So what's really interesting is that the sun can really save lives too, because you can actually provide yourself with additional help from the ecosystem. There's a balance. There's good bacteria, there's bad bacteria. But if you know how to utilize it to your advantage, not to the point where you kill yourself, it can actually save your life. So that's actually pretty cool. So that leads me to believe that maybe there could be bacteria out there that could also survive the sun's rays, and it's more immune to, like, let's say ultraviolet radiation rather. It can survive ultralight radiation, as well as saving itself from like photon blasts and all that, you know, gamma ray radiation or ultraviolet lights and gamma ray bursts and all sorts of other crazy like radioactivity. It's actually very interesting to consider what we don't know. So yeah, that's actually just 10 things that I was able to come up with. But again, if you like these kind of videos, you know, again, please subscribe. I'll be making more videos like this, and I find this stuff very interesting. So we'll have to update that when the time comes, though.